Hello students, good evening all. This is your KP sir on a YouTube live now, and welcome to Unacademy. So the discussion today is related to engineering hydrology for AE or AEE. So we have completed 2 sessions on it. Now today third session related to engineering hydrology for AE or AEE. So is everything clear? Shall we move on? Yes, good evening everyone. We'll go ahead. Today we'll start with the topic measurement of precipitation. Today's topic we are going to discuss is related to measurement of precipitation. Good evening Shreyas, good evening Suvarnam, good evening Prakash. Yes, good evening Abhinav. We'll go ahead. Measurement of precipitation. Precipitation is measured using the instruments. What are the instruments? Rain gauge model of measurement using rain gauge. Are the very old method and costlier method, radar measurement. Radar measurement. Measurement of precipitation carried out with respect to rain gauge and radar measurement. Rain gauge, also called, very important, the other names, ombriometer, hyetometer, ombriometer, hyetometer. Good evening Rudra Singh. Good evening Priyanka. I know you, Banu Prakash. I never forgot you. Don't worry, Banu Prakash. Pluviometer. Pluviometer. The other names for the rain gauge: ombriometer, hyetometer, pluviometer. Again, rain gauges have been classified into 2 types. Based upon how they will perform the work, rain gauges again classified into non-recording rain gauge, recording rain gauge. Rain gauges classified into 2 categories: non-recording rain gauges and recording rain gauges. Yes, good evening Rahul. Non-recording. Again, non-recording differentiated into 2 types. One is Simon's rain gas. The first model of non-recording rain gas, Simon's rain gas. Second one, IS non-recording rain gas, Indian standard non-recording rain gas. Again, recording rain gases differentiated into three types. Tipping bucket type, tipping bucket type. Good evening, Kapil Soni. Yes, Rahul. IS non-recording rain gas. Weighing bucket type. And the last one, float type or siphon mechanism. Float type or siphon mechanism. So these are the instruments used to measure precipitation. Rain gas and radar measurement basically. Rain gas also called ombriometer, hyetometer, pluviometer. Non-recording rain gas. 90% of rain gases provided in a certain location. 90% of rain gases provided in a certain location, non-recording. 10% of rain gases are recording. Clear? 90% type of rain gases provided are non-recording. 10% type are recording type. Because recording rain gauges are costlier, expensive. We are not going for all types recording rain gauges because recording rain gauges are expensive rain gauges. What happened, Rudraji Singh? What you are saying? Rudraji Singh, what you are saying? I am not getting. Okay, is it clear? Is it clear? We'll move on. I will explain one by one. Okay, Ruxar Bano. Non-recording type of rain gauges. Non-recording type of rain gauges. So whatever I have written RG, RG is not RGV. Okay, it is rain gas. Don't take it as RGV. It is RG rain gas. Okay. So non-recording type. The name itself provide you the information. What is the information provided? What is the information provided? Non-recording type. Non-recording does not record any result. Is it give you by recording mode? Is it give you any kind of result? Will non-recording type of rain gauge will give you any kind of result? Is it give any graph? Is it provide any value to you? No, no. Non-recording rain gauge does not provide any kind of record of the results. Then what it will do? The only function of non-recording rain gauge. The only function of non-recording rain gauge. Tell me any one of you. Just the function of non-recording rain gas is collection of water during rainfall. When rainfall is occurring at that time, water is collected. Just non-recording type of rain gauge will perform the function of collection of water during rainfall. Then what we will do with the collected water? Then we'll estimate manually the person or the observer who is associated with the rain gas. The person or the observer who is associated with the rain gas, he is measuring volume of water collected. Non-recording rain gas has a container. That container will collect the water. How much volume of water collected? Using the measuring jar, what we are measuring? Volume of water collected. Who is collecting? The container in the non-recording rain gauge. Then clear, the water from the container is transferred to measuring jar. We have a measuring jar, we will transfer to it. Measuring jar you have seen in the chemistry lab, I think so. 5 liters, 2 liters, 1 liter capacity measuring jars are available. So from the container from non-recording rain gauge, water is transferred from that container to measuring jar. Then volume of water collected is measured. Then divided by volume of water collected divided by area of collector. The container which collects the water, that is called area of collector. It gives depth of rainfall per unit depth, unit area, depth of rainfall per unit area. Along with this, the observer who is associated with the rain gas station, he note down manually the time of occurrence of rainfall. Clear? How many hours? What is the starting time of rainfall? What is ending time of rainfall? How many hours rainfall occurred? The observer who is associated with the rain gas station, he is going to measure duration of rainfall. Already we know depth. Now depth by duration, what we will get? By using first formula, depth of rainfall. Observer noted starting time and ending time of rainfall. Depth of rainfall by duration, what he is getting? Intensity of rainfall. Ranveer Pratap, you send WhatsApp message to me. In the end of the session, I will provide my mobile number. I will add you to the WhatsApp group so that every day you will get a timetable of and the link of the class. Yes. So what is the work done by non-recording? Is it doing any measurement? Is it giving any reading? Is it providing you any graph? No, nothing. Only one function non-recording type of rain gauge will do. It perform collection of water. Who is doing remaining work? Manually, the observer, the person who is allocated with the non-recording rain gauge. The person or observer who is associated with the non-recording rain gauge, he only perform everything. Just non-recorded type of rain gauge will perform collection of water. Collected water transferred to measuring jar, then volume is estimated. Then volume by area of collector is depth. Depth by duration is equal to intensity of rainfall. How it looks? Non-recording rain gauge. This is a non-recording type of rain gauge. So below ground level we are excavating. This is ground level. This picture gives you clear information. This is ground level. We are excavating 600 mm, 600 mm, 600 mm. Then a concrete block is provided. Cement concrete support. Means, so this is ground level. We have excavated below ground level. And after excavation below ground level, we are making a cement concrete support. So this is a cement concrete support provided. So into that cement concrete support, we are placing the container collector. So this is the container or collector which is going to be placed on the cement concrete support. So this is only collector which collects water. Clear? This is only the collector which collects the water during rainfall. The collector capacity, if it is a Siemens rain gauge, the collector capacity is 1 to 10 liter. Siemens, if it is, we are discussing about a Siemens rain gauge, collector capacity, collector carries, collects water quantity of 1 to 2 liter. Siemens rain gauge, the collector will collect water quantity of 1 to 2 liter. And in the top of collector, will water directly fall down? No. We are placing a funnel at the top of the collector. This is the funnel provided. So this is what we have given. The funnel is provided. I think you understand by this diagram. This is the funnel provided here. Collector is placed in a box. So water droplets from the atmosphere, drop by drop, they fall down into funnel, then funnel to collector water droplets. So rain water droplets are collected in the collector. Rain water droplets are collected in the collector. Is it clear? Very important thing. You can write down very clearly. Diameter of collector. Diameter of collector provided 12.7 centimeter and the height of rain gas. Height of rain gas provided, that is 30 centimeter. These two values are very important for you. What is the diameter of collector? Theoretical question they will ask you. This diameter of collector clearly written 127 mm. Whatever in the picture, the values provided in millimeters. You got it? In the picture, the values provided are millimeters. Okay? 12.7 mm is the diameter of collector. 30 centimeter is the height of rain gas. So water fall down from atmosphere to funnel. Water fall down from atmosphere to funnel. Funnel will collect and release water into bottle, collector. Then the collector, after completion of rainfall, will transfer water from collector to measuring jar. Will estimate volume of water collected, divided by area, will get the depth of rainfall. Okay? Then, what is the difference between Siemens rain gas and IS? IS, non-recording rain gas. So everything is same except two phenomena. Just it is a improvised. IS non-recording rain gas is a improvised Siemens rain gas. You can write down like this only. Improved. IS non-recording rain gauge is a improved Siemens rain gauge. What is improved in the Siemens rain gauge? First of all, material. In Siemens rain gas, it may be glass or aluminium material. Now, IS non-recording rain gas, fiber reinforced polymer, FRP material. That is improvement in the Indian standard non-recording rain gas. You understand the point? Siemens rain gas is made of glass or aluminium, but Indian standard non-recording rain gas is provided with a fiber reinforced polymer FRP material. And also we are increasing capacity because 1 to 2 liters is a small volume only. Na? If a heavy rainfall occurred for 8 hours, immediately bottle is filled. So for every heavy rainfall, every time, within 2 to 3 hours, we need to change the bottle, collector. So to avoid that problem, for every 2 hours, 4 hours, 8 hours, change in the collector is, during the rainfall is a continuous process. Instead of that, you increase the capacity, you take capacity of collector 2 to 10 liter. What is capacity here? Simon's rain gas, written clearly. Collector capacity here 1 to 2 liter. But Indian standard non-recording rain gauge collector capacity is 2 to 10 liter. Because to avoid replacement of collector if heavy rainfall occurred, time to time we need to replace. Instead of that, we are going for capacity 2 to 10 liter. These are the most important two differences between IS non-recording rain gauge and the Simon's rain gauge. Clear? We'll move on now. Disadvantages of non-recording rain gas. The disadvantages of non-recording rain gas. Observer must be present. A manual. Presence of observer 24/7. Presence of observer 24/7. Then replacement of collector. Replacement of collector after filling. For example, today morning at 8 a.m. rainfall started. It is a continuous rainfall 12 hours, 8 a.m. to 8 p.m. After 4 hours or 5 hours, the bottle is completely filled. Collector is completely filled. Now, the observer came. He can open the screws and buttons in the metal container. This is a metal container. No? He is going to open the screw and bolts in the metal container. Then he can take out the bottle. He placed the new bottle and again he fit all the screws and bolts in the metal container. So while observer is doing this process, will you stop rainfall? Can you say we are placing rain gas bottle, wait for some time, we need to measure you, wait for 10 minutes gap, so we will replace old container with new container. Shall you say to the rainfall? Tell me, will you say that to the rainfall? Please stop rainfall for 5-10 minutes, we will replace the container. Is it possible? It is not possible. So, during that replacement of old container by new container, we are taking out filled in container and placing empty container. During this time, some quantity of rainfall water is not collected. So during this time, what happened? Some quantity of rainfall water missing collection of water during replacement. So water is not collected now. Missing collection of water at the time of replacement. Missing collection of water during replacement. Then water loss or pouring or wastage. While you are transferring from collector to measuring jar. During transfer, because you need to measure volume, no? So during transfer from, while you are transferring from collector to measuring jar, some quantity of water spilled out. Will you do it carefully? So most of government employees, observers, so they will just transfer from one container to other container. So spill out of water, loss of water, wastage of water will happen. Even a common man, normally you are transferring water from one container to other container in the lab. Some droplets of water is getting wasted. And finally, everything related to non-recording rain gauge is a manual work. Everything related to non-recording rain gauge is a manual work. So during this manual work, will you get accurate value? So can you perform? You got government job, you become observer in the rain gas station. Every day, throughout 365 days, you are waiting for rainfall, suddenly rainfall occurred. Will you do perfectly your manual work? So even though you are doing perfectly your manual work, but the value obtained is not 100% accurate. The value obtained is always approximate value. Always approximate value. So to overcome all these disadvantages, we have recording rain gauges. Here, to overcome all these disadvantages of non-recording rain gauges, we have recording rain gauges. Okay. Recording. We'll discuss about recording type of rain gauges. Recording type of rain gauges. Records rainfall data. What they will do? Record rainfall data in the form of a rainfall masker. In the form of a rainfall masker. Very carefully write down, because this is important previous question. Recording rain gauges will record the data in the form of rainfall masker, and plot the graph against time. Time also considered properly here. Plot the graph against time using, what is using? Clock driven drum. Automated clock driven drum. It utilizes automated condition of clock driven drum associated with pen and graph sheet. Associated with pen and graph sheet. So what is it providing? A recorded evidence for the rainfall data. Clear? Recording type of rain gauge is going to provide a recorded evidence. What is recorded evidence? Graph. Graph is the recorded evidence to the rainfall data. Understand? Graph is the recorded evidence for the rainfall data. So what graph it is going to plot? It is going to plot time versus cumulative depth of rainfall. time versus increased depth. Time to time depth increases. No? Rainfall happened for 6 hours. First hour depth, second hour depth, third hour depth. Time to time all added up. No? If you say rainfall happened for 2 hours, rainfall happened for 4 hours. Rainfall happened for 2 hour depth, 0 to 2 hours. Rainfall happened for 4 hours, 0 to 4 hours. 0 to 4 hours will include 0 to 2 hours, 2 to 3 hours, 3 to 4 hours. So it goes on increasing the curve. So it provides a cumulative depth of rainfall versus time. That cumulative depth of rainfall versus time, what we call it as rainfall mass curve. How it is plotting the curve? So the rain gas is automated rain gas associated with a clock driven drum. Here rain gas is an automated system, clock driven drum. Best example I will tell you. In your solid mechanics laboratory, strength of materials laboratory, I think you have seen UTM, universal testing machine. Have you seen it? Have you done the experiment on UTM? If you have done the experiment on universal testing machine, who is plotting the graph? Are you plotting the graph or the machine is plotting the graph? Tell me. Are you plotting the graph or machine is plotting the graph? With increase or decrease of the load, pen associated with the machine, universal testing machine, move on, increase. With increase of load, goes on increasing. With decrease of load, fall down. The pen associated with the UTM is going to plot the graph. Is it not? So, same manner here. See, this is the picture. This is a clock driven drum associated with pen arrangement. So here pen with ink is there. The drum is rotating continuously like this. This is graph sheet. This is graph sheet. So graph is going to be plotted by the pen. Very clear picture I will show you. See here. So clearly, I think now it is visible very much clearly to you. So Tuesday, Monday, Wednesday, the total day 24 hours they are differentiated into one box. What is one box equal to? On the graph sheet, one box is equal to 0 to 4 hours. Second box, 4 to 8 hours. Like that, total 6 boxes one day is equal to 6 units on the graph sheet. One day is equal to 6 units on the graph sheet. Yes, plotting the graph automatically done. Yes, very good. Is it clear now? This is a clock driven drum associated here. Clock driven drum provided here. The drum rotates with respect to increase in depth of water. Drum rotates with respect to increase in depth of water. So with respect to movement or rotation of drum, this movement of pen is going to change. So ultimately with it, the graph is going to be plotted, increased graph is going to be plotted. You got the point? Always it is increasing only the mass curve. Mass curve means cumulative values you are taking. If I say cumulative values, time 0, 2, 4, 6, 8, 10. Rainfall provided. Rainfall provided 0, 4 mm, 3 mm, 10 mm, 6 mm, 2 mm. So what are cumulative values? Now I need cumulative rainfall. We can add na 0, 4, 7, 7 plus 10, 17, 17 plus 6, 23, 23 plus 2, 25. The value goes on increasing only now. On this graph sheet, if you are plotting. So the value will be goes on increasing only. Na? The graph will be looking like this only. Na? Is it clear? So we can write it down. Na? We can write down 0, 4, 7, 17, 23, 25. So will be any fall down of the graph? Graph continuously goes on increasing because cumulative rainfall versus time they are plotting. The cumulative rainfall versus time is always increasing. What is the last value is representing? Last value is representing total depth of rainfall. The last value of cumulative that represents total depth of rainfall. You understand it? Is it clear for everyone? Anyone needs repetition for it? Anyone needs repetition for it? Okay. Total depth of rainfall, Funistry. The final value of rainfall mass curve. The final value of rainfall mass curve, this value. This is representing total depth of rainfall. That is only representing total depth of rainfall. Okay, clear for everyone? Nice. Weighing bucket type of rain gauge. Weighing bucket. The name itself give you information, clear picture. From the funnel, water is falling down. Water droplets collected. From the funnel, water droplets falling down into the bucket provided on the weighing balance. So what happened if you are placing some weight on the weighing balance? So first you placed some 500 grams weight. After you placed one more 500 grams weight. The weighing balance platform, this is platform of weighing balance, platform. And below the platform, what it contains? It contains a spring balance, very important. Below the platform, it carries a spring balance. What happened to spring? Weight goes on increasing, spring compresses. No? You got the point? If weight of the water in the bucket, in the top bucket, weight of water in the top bucket goes on increasing. So weight increases, compression of the spring balance goes on increasing. So spring is getting compressed. This spring compression is transmitted to this information. This is called link and lever joint. Link and lever joint associated with clock driven drum. This is revolving drum, clock mechanism, and this one is pen. You got it? With respect to time clock mechanism, drum is rotating. With respect to clock time, drum is rotating. What the pen will do? With the compressions provided by spring balance, link and lever joint, the pen will mark on the graph sheet. The pen will mark on the graph sheet. So this is called weighing bucket type of rain gauge, mostly used in UK. Weighing bucket type of rain gauge, mostly used in UK. Okay, we'll move on now. Actually, you don't have any question related to recording type of rain gauges, just they will ask the names. Only question related to for AE and AEE, not only for AE AEE in any exam till now, there are no questions related to recording type of rain gauges, just only they will ask you about names. Tipping bucket type of rain gauge. Tipping bucket type of rain gauge. This is most suitable for remote places. Tipping bucket type of rain gauge is most suitable for remote places or inaccessible places. What are remote places or inaccessible places? Dense forest areas, hills and mountains. Regularly we are unable to go to those places. No? Everyday observer can go for it. Dense forest area. Will everyday observer can go for it? No. For those dense forest area, hilly areas, mountains, we place tipping bucket type of rain gauges. Clear? Everyday observer is not going to perform, going there, location. So for those inaccessible places, dense forest area, hilly area and mountains, tipping bucket type is most suitable. Two buckets are provided here. So this is the picture which shows this is bucket 1 and this is bucket 2. Two buckets are provided. Rainfall falling down through this into bucket 1. Bucket 1 is like this, slant position. With increased water content in bucket 1, the bucket 1 in the slant position slowly move on, coming to normal. Then there is a movement of platform. Platform will move immediately whenever bucket 1 come to normal position like this. This platform is there. This platform is going to show one forward movement. Just it moves forward direction or just it moves backward direction. By filling one bucket. For example, bucket 1 is filled, it is come down to flat position. Immediately it shows one forward movement. When it shows forward movement, which bucket is coming below the funnel? Bucket 1 and 2 like this. This is bucket 2, this is bucket 1. Funnel is located now. Then it shows somewhat forward, it moves forward direction. Empty bucket, bucket 2 will come now. Bucket 2 will come to funnel, below the funnel. Bucket 1 is forward. Then bucket 2 is filling water, immediately bucket 1 is empty. Both occurs at the same time. Filling of bucket 2, emptying of bucket 1, both occurs at the same time. Tipping mechanism. Clear? So from here this bucket is filling the water. From here this bucket is emptying the water. So filling the water in the bucket 1, emptying the water in bucket 2. Both occurs simultaneously. So for one complete filling of bucket, what is equal to? One complete filling of bucket capacity. One complete filling of bucket capacity is equal to, very important, 0.25 mm depth. 0.25 mm depth of rainfall. So by forward movement, it makes information, gives information to clock driven drum. What the clock driven drum and pen will do? Here information to pen is given one forward movement, one line. One backward movement, one more line. Again one forward movement, one line. It is not now cumulative rainfall curve. Only weighing bucket type, float type are cumulative rainfall mass curves. Tipping bucket is not forming mass curve. Just the pen associated with the tipping bucket will form vertical lines. One vertical line is equal to 0.25. Clear? One vertical line is equal to 0.25. Finally, by the end of rainfall, what you are doing? You are counting the number of lines. Clear? Number of lines. Depth of rainfall is equal to. By the end of rainfall, you are taking graph sheet. You are measuring depth of rainfall is equal to number of vertical lines. Number of vertical lines into 0.25 mm. So graph sheet is not forming mass curve here. Clearly remember, tipping bucket type graph sheet is not forming mass curve. It forms, as I shown, vertical lines. Just plot one line like that, vertical lines. One vertical line is equal to 0.25 mm depth of rainfall. We'll move on now. This is a float type or siphon mechanism. Float type or siphon mechanism. What is this? Float type or siphon mechanism. What is the importance of this? Indian recording rain gauge. Indian recording rain gas. Float type or siphon mechanism. Float type or siphon mechanism is Indian model of recording rain gas. So funnel is loading the water. Funnel is loading the water through it. Then with increasing water quantity, what happened? Float rises up. No? You are throwing some plastic ball or thermocol sheet or a cork. If water depth rises up, float also will rise. No? Float is a material which increases or decreases its elevation with respect to water. So, volume of water entering into this float chamber, this rectangular box is called, float chamber. Volume of water entering into float chamber increases. Rainfall water increases. What happened? Float rises up. No? Water is falling down into the float chamber. So, amount of water increases. Depth of water rises up. Float depth also rises up. Same again, rainfall mass curve, pen goes on increasing. Pen goes on increasing with respect to rise of water. Up to what level? Up to a depth of 150 mm. Up to a depth of 150 mm. When the float chamber is nearly filled, immediately we open siphon chamber. What is the siphon mechanism? Siphon mechanism is required for emptying the water. For emptying water from float. Emptying water. Water is transferred. We are going to open the valve located here. Water is transferred from float chamber to siphon chamber. Siphon chamber will empty the water. Again, I am repeating for clarity. From the funnel, water is entering into float chamber. From the funnel, water is entering into float chamber. Drop by drop, water is entering. With increase in water surface elevation, float is placed here. So initially water is here. Consider this pen is float. Okay, I will take this one. This is the float I have provided. This is water surface. So when water rises up, slowly this also rises up. No? The elevation of float also rises up. No? When the elevation of float reaches to maximum point in the float chamber, then immediately you open the valve located here. Then water transferred from float chamber to siphon chamber. Siphon chamber will pump the water vertically upward direction. Then water is emptied to downward direction. So water is falling down here. Water is falling down here. You got the point? Then float fall down. Whenever float fall down, float is at the top, it reaches to 150 mm. Whenever float come to normal position, a vertical line is plotted, pen fall down. Pen rises up along with rise of float. Whenever you emptied water in the float chamber, immediately float come to downward. Is it not? So I have placed it here. This is water, this is the float. Float rises up, reaches maximum. This is maximum point 150 mm. 150 mm. Then pen also reaches to maximum point. The pen is plotting on the graph like this. So pen is also in the top position. You opened siphon. When siphon is open, float fall down. Pen also fall down. So it is falling down exactly in vertical position. Clear? It is falling down exactly in vertical position. So what is the maximum capacity? Maximum capacity 150 millimeter, mm, 15 centimeter. 150 mm, 15 centimeter. Pen fall down. Still rain is continuing. Still rain is continuing. Again slowly pen rises up with raise off float, raise off float, raise off float. Again up to 150. Same continued till the end of rainfall. When it is fall down, one vertical line. So one complete inclination is equal to 150 mm. After completion of rainfall, you take the graph sheet and you can analyze it. Got it? Clear for everyone? This much mechanism not required for your AE A-double exam. Only one point you remember. Indian type of recording rain gauges. What is Indian type of recording rain gauge? Float type or siphon mechanism. For what purpose siphon mechanism required? For what purpose? Emptying the water. For what purpose siphon mechanism required? For emptying the water. Okay? We'll move on. Number of rain gases required. Number of rain gases required. So we are discussing here according to Indian standards. Indian standards. First one. For plain, flat, normal areas. Plains, flat regions and normal areas. Clear? For plain, flat and normal area. For this, we will provide one rain gas per every 520 kilometer square. One rain gas per each. Yes, Ruksher-Bano, that is a numerical calculation. First, according to theoretical Indian standards, I am talking. Ruksher, I think you got it. Ruksher-Bano, theoretical Indian standards I am writing. One rain gas per every 520 kilometer square area is required. Then, regions at an elevation of 1000 meters, 1 kilometer or above. Clear? Regions at an elevation of hills, mountains or other regions from the ground level at an elevated region of 1 kilometer or above. Then again one rain gas per 260 kilometer square. For every 260 kilometer square area, one rain gas is required. For every 260 kilometer square area, one rain gas is required. Then, dense forest areas. Dense forest area or wetted regions. Heavy rainfall occurring regions. Dense forest area or heavy rainfall occurring wetted regions. Yes, half of plain area, correct? Again one rain gas per 130 square kilometer. 1 rain gauge per 130 square kilometer. So these are the three different conditions. These are the three different conditions of analysis of rain gauges for different areas. According to different area conditions, we have taken for plains, flat and normal area, 1 rain gauge per 520 km square. Regions at an elevation of 1 km or above, 1 rain gauge per 260 km square. Dense forest area or wetted regions, 1 rain gauge per 130 km square. Okay. So now we are coming regarding numeric objective questions. Plus hill area 130 square kilometer Ruxarbano. It may be hill area, dense forest area, whatever it may be. Final value wetted region, we have given 1 rain gauge station for 130 square kilometer. So we are coming for objective questions to solve. That numerical model for rain gauge station estimation tomorrow we'll discuss. Problems for rain gauge station, coefficient of variation by error whole square. Because those are not given in AEA exam. Theoretical questions only provided in AEA exams. Okay. So objective questions we are discussing now. Recording type rain gauge gives. What the recording type of rain gauge gives? Oh, answered A. A. Any doubt regarding this? Everyone knows, na? Mass curve of rainfall. We have written clearly and also drawn the curve. Curve is goes on increasing. Cumulative rainfall versus time. The nearest object from a rain gauge should be at a minimum distance equal to. The nearest object from a rain gauge should be at a minimum distance equal to. This was not discussed. Wantedly only I have not discussed. Because if I will tell this in the theory, you neglect it. So if I explain you in the question, objective question, you remember it very well. So tell me, what is the answer? Oh, very nice. Everyone knows it. Twice the height. Twice the height of object, not rain gauge station. Remember, twice the height of object. The nearest object from a rain gauge should be at a minimum distance equal to twice of its height. Twice of its height. Whose height? Object's height. Twice of height of object. Which of the following is a non-recording rain gauge? We have 4 types of rain gauges named here. Which of the following is a non-recording rain gauge? Tipping bucket, Simon's weighing bucket, floating. What is the answer? B. Simon's. Written clearly. Which of the following is a non-recording type of rain gauge? That is a Simon's rain gauge. Same question. Here, same question. Reverse order they have given. Simon's rain gauge is a. Previous question, non-recording rain gauge is a. Now, Simon's rain gauge is a. It is a non-recording. But carefully observe the spelling. Siphon, Simon. Clear? Carefully observe the spelling. Suddenly if they give siphon, don't confuse. This is Simon. Simon is non-recording. Simon is non-recording. Siphon is recording. So, just 2 words difference. Clear? IPHYM. Carefully read the spelling and then answer the question. Simon's is non-recording. The type of rain gauge used for measuring rainfall of an area. The type of rain gauge used for measuring rainfall of an area. Where we are considering area? Are you considering any recording type of rain gauges? Are you considering any area? No. In a recording type of rain gauges, we are not at all considering area. Only in a non-recording type of rain gauges, SCIE months. SCIE months. GAUGE. Sandeep Kumar, GAUGE is correct spelling. GAUGE is the correct spelling, Sandeep Kumar. Standard height of a rain gauge is. What is standard height? I have written clearly standard height of 30 centimeter. Written now? Standard height of 30 centimeter. Diameter of 12.7 centimeter. Clearly mentioned. So answer is 300 mm. Answer is 300. Look sure it is C, it is not B. Look sure it is C, it is not B. Rainfall mass curve shows the variation of. Rainfall mass curve shows the variation of. What we are plotting in the rain gauge? Rainfall mass curve is a cumulative rainfall with the time. Accumulated flow. Sometimes they will give like this also, remember. Rainfall mass curve. Accumulated flow versus time. Accumulated flow versus time. Cumulative rainfall versus time. According to Indian standards, the number of rain gauge stations for an area of 5,200 kilometer square in plains. So for plains, we have written clearly, one rain gauge station can cover 520 kilometer square. For 5,200 kilometer square, how many required? 10 only, no? You got it? For one rain gauge is going to cover 520 kilometer square, 5,200 kilometer square. So 5,200 divided by 520, 10. Number of rain gauges, 5,200 divided by 520, 10. We will continue tomorrow. In Unacademy Plus course, paid course, I am going to start irrigation engineering full length from August 12th, which is a 60 hours session, and August 24th onwards, engineering hydrology, which is a 60-hour session. So total irrigation as well as engineering hydrology, I am teaching 120 hours, which cover full length gate, ESC, sscje, any state government AE, AEE, PWD, any kind of exam. A single course for your entire all kinds of competitive exam preparation. Okay? A single course. Join plus effective study, break, gate and ESC. Nice. You got it? In 120 hours in a single course, you are going to study everything, gate, ESC, sscje, AEE. Generally, if you take gate coaching, it is restricted to gate coaching only. Again, for state government exam, you have to go for another coaching. No need here in Unacademy Plus course. We are teaching paid course, a single solution for all types of competitive exams. So take Plus subscription as early as possible. Use my code KPCL. Okay, and those who want class links, everyday class timetable and link, those who require, message to my number 898593312. Okay, tell your friends to join plus subscription. Follow me in Unacademy classes also. So tomorrow I am going to teach, tomorrow morning, very important announcement this is, most of you require. Tomorrow I am teaching changes in GATE 2021. Not in YouTube, remember this is in Unacademy. Changes in GATE 2021 I am teaching. Tomorrow at 10:30 a.m. Tomorrow at 10:30 a.m. I am teaching in Unacademy platform, not in YouTube. I think most of the students require this. So most of you need this, the latest modifications in GATE platform. Okay. So everyone attend the session, utilize the opportunity. And also tomorrow regular 4 p.m. we have class Hydrology for AE and AAA. We'll continue tomorrow. Okay. So 10:30 a.m. morning Unacademy platform, changes of GATE. 4 p.m. afternoon Hydrology for AE, AAA, YouTube. We'll continue tomorrow. Thank you one and all.